Welcome back. Today, we're diving into something pretty massive, an ebook called the C++ Lab Programs Collection. But do me a favor, erase the idea of some dry, dusty textbook from your mind entirely. Instead, think of this as a hands-on, high-octane toolkit. It's a highly structured curriculum built specifically to transform you from someone who just casually reads about code into someone who actively builds with it. Okay, let's look at our roadmap for today. We'll start with the ultimate C++ roadmap. Then hit level 1, the fundamentals, move into level 2, object-oriented core, step up to level 3, advanced architecture, and finally, we'll look at bridging theory to practice. Right, let's jump straight into section 1, the ultimate C++ roadmap. You know, this curriculum is not messing around. It's an academic powerhouse designed for really intensive degree programs. Think BE, BTech, and MCA. And its core philosophy? It's brilliantly simple. Reading about C++ just leaves you stranded in abstract theory. But actively writing executable code, which is exactly what this collection forces you to do, builds actual muscle memory. It's all about active execution, not passive reading. And when I say massive, I literally mean it. This single ebook actually packs in 6 distinct collections of lab programs all rolled into one. I mean, that is a staggering amount of hands-on material. We're talking hundreds of distinct programs that cover everything from basic syntax all the way to advanced data structures. Now, to keep us from getting totally overwhelmed, the smartest way to tackle this beast of a repository is by breaking it down into 3 distinct levels. You step from the fundamentals, straight into the object-oriented core, and finally peek at advanced data structures. Honestly, it's kind of like leveling up your character's stats in a game. So let's get into it with Section 2, Level 1, the fundamentals. Think of this as the tutorial stage. You absolutely have to master these foundational mechanics before you can take on the big stuff. So early programs focus heavily on switch cases, basic input/output operations, inline functions to optimize speed, and core mathematical logic using primitive data types. You're basically learning how to hold the hammer before you try to build the whole house. But hey, even here in Level 1, the tasks are immediately practical and super rewarding. For instance, right out of the gate, exercises 1 and 2 have you building a menu-driven temperature converter to swap between Celsius and Fahrenheit, and a geometric calculator to find the area of circles, rectangles, and squares. So you're building real, usable utilities from day 1. Moving right along to Section 3, Level 2, Object-Oriented Core. Here's where we really accelerate the pacing, we're moving away from just typing out sequences of commands and stepping up to architecting intelligent systems. The curriculum leans heavily into encapsulation. Think of it like a blueprint. You're taught to group related data and logic into a single unit, a class, and use it to instantiate physical objects in your program's memory. It completely shields the internal mechanics from outside interference, which makes your code incredibly robust. And this brilliantly illustrates the real-world application of all this. In exercises 9 and 10, students aren't just memorizing the abstract concept of inheritance. No, they are actively building functional employee payroll systems and multi-level student grading trackers. They learn exactly how a specialized salary class can inherit basic employee details to calculate net pay. It's instantly applicable knowledge. Then we tackle polymorphism. It's a fancy word, sure, but it's a beautiful concept. It's basically the ability of different objects to respond to identical messages, but each in its own unique way. The ebook explores this super thoroughly, guiding you through compile-time polymorphism using function overloading and runtime polymorphism using virtual functions. A really standout example from the text is the Digital Library Lab. You build this system that manages completely different media types, like books with page counts and tapes with playtimes, all under one unified pointer system. So when you tell the system to display details, runtime polymorphism kicks in and ensures the program dynamically chooses the right output format, whether it's looking at a book or a tape. It's pretty seamless. All right, things are about to get intense in Section 4, Level 3, Advanced Architecture. Okay, the training wheels are officially off. Welcome to the boss levels. These labs push you straight into generic programming with templates, managing your own RAM with dynamic memory allocation using new and delete, and building really complex nonlinear data structures like trees, linked lists, and stacks completely from scratch. The absolute peak of this learning journey involves some serious heavy lifting. For example, one lab demands that you implement robust error management using 5 different exception classes, including custom ones, to catch things like age restriction errors or that classic universe-ending divide by zero error. Another has you carefully traversing and managing node insertions in a full-blown B tree. Seriously, if you can code these, you can code almost anything. Finally, let's wrap this all up with Section 5, Bridging Theory to Practice. Now, what's really interesting here is how a student actually survives a journey this rigorous, and it really comes down to incredible consistency. Every single lab in this massive collection follows a strict 5-part structure. You get a clear program description, a step-by-step logic breakdown before you even glance at the syntax, the full executable code, the exact expected output to verify your work, and finally, expert remarks to give you that much-needed context. You're literally never left guessing. And honestly, those expert remarks are invaluable. The book frequently bridges the gap between older academic environments, like Turbo C++, and modern IDEs like CodeBlocks or Online GDB. It explicitly tells you how to update legacy headers to modern namespaces. It's literally like having a seasoned tutor sitting right next to you, warning you about weird compiler quirks before they break your code. So we've seen the roadmap, from basic switch cases to polymorphic digital libraries and complex B trees. The structure is laid out perfectly, just waiting for you to execute it. So I'll leave you with this provocative thought. Which level are you going to conquer first? Are you ready to dive into the code and compile your future? Thank you so much for joining me on this explainer. And hey, happy coding!